Coming to this next code number 15JM110304. For any two events AB on this in the sample space, we have to see which of the following options are correct. That means each of the option I have to verify here. Coming to the first option, A option. According to the usual notation, here it is probability of P of A slash B, that means the conditional probability of A when B has occurred. I want to write here it is probability of A slash B. I can say according to the definition, here it is यहाँ पर probability of A intersection B और probability of B होगा. उसके बाद हम यहाँ पर देख सकते हैं, हमें मालूम है probability of A union B according to the addition theorem. According to the addition theorem, I can write this as probability of A plus probability of B minus probability of A intersection B. Probability of A plus probability of B minus probability of A intersection B. अब हम यहाँ पर inequality बनाएंगे. Inequality बनाने के लिए हम यूँ बोल सकते हैं कि whenever it is probability of A union B, I can say probability of A union B will be always less than or equal to 1. That means यहाँ का ये एक्सप्रेशन राइट साइड वाला एक्सप्रेशन भी लेस देन और इक्वल टू 1 होना चाहिए. आई कैन राइट प्रोबेबिलिटी ऑफ ए प्लस प्रोबेबिलिटी ऑफ बी माइनस प्रोबेबिलिटी ऑफ ए इंटरसेक्शन बी इज लेस देन इक्वल टू 1. इस एक्सप्रेशन से हम यहाँ पर थोड़ा सा स्वैप करेंगे, इसको इधर कर देंगे, सो दैट आई कैन से प्रोबेबिलिटी ऑफ ए प्रोबेबिलिटी ऑफ बी माइनस 1 लेस देन और इक्वल टू प्रोबेबिलिटी ऑफ ए इंटरसेक्शन बी. यानी हम यहाँ पर देख रहे हैं probability of A intersection B is less than this is less than or equal to this one. I mean to say I want this type of expression. तो हम यहाँ पर डिनोमिनेटर में देख रहे हैं probability of B, न्यूमरेटर तो मिल गया है यहाँ पर, तो हम बोलेंगे probability of B से डिवाइड कर लेंगे. Yes, I can divide, I can say divide by probability of B. Probability of A plus probability of B minus 1 probability of B. This is A intersection B, probability of B. Now this whole expression is greater than or equal to this. I can write here probability of A intersection B upon probability of B is greater than or equal to probability of A plus probability of B minus 1 by probability of B. Hence I can say that probability of A slash B is greater than or equal to this, and which is A option is correct one. Coming to this B option, I have to see here it is A union B bar. I write here it is LHS expression separately and RHS expression separately. A union B bar, then I can say here probability of A union B bar. I want A but not B. Then I can say that this according to this sample space is A here and here it is B. If I want to write here it is A union B bar means here it is outside this region and A is this region. So if I take here it is the union of these two, then I can say that probability of A union B bar can be written as this only this exception of this one. That means I can say here it is 1 minus probability of A intersection A bar intersection B. Now in this one it is something like this, probability of A minus probability of A intersection B. Let us see here it is in the right hand side. This is A and this is B. I have to see here it is A intersection B. This is the region A intersection B. In the RHS, if I see here, I can say that probability of A minus probability of A intersection B. A is this whole and intersection B is this one. If I subtract from this whole this region, then I will get only this region. So I can say it is very clearly RHS is the probability of this region and the LHS is probability of this outside and this region. So I can say that this region and this region are not the same, hence the probabilities cannot be same. Coming to the third, C. I have to see here it is probability of A union B. Probability of A union B, and it is given that AB's are independent events. I can write probability of A plus probability of B minus probability of A into probability of B. In the addition theorem, at the place of A intersection B, I am writing probability of A into probability of B. It is known that whenever the events are independent, we can say A intersection B is equal to probability of A into probability of B. This condition is given in the question, so I am writing here. उसके बाद यहाँ पर अगर देखें तो इन दोनों से हम probability of A कॉमन निकालेंगे, तो हम यहाँ पर लिख सकते हैं probability of A, it is 1 minus probability of B. Then I can say this is probability of B. So ये बन जाएगा probability of B bar. So it is probability of A into probability of B bar. I can write B complement. Now we have to go by the definition. In the right side I want B complement, here it is only B. I can write that probability of B in terms of probability of B complement. I can say it is 1 minus probability of B complement. Now a one constant is addition here, this one I will write here, and from this and this term I can say probability of B bar is common. 1 probability of A probability of B complement minus probability of B complement. From this second and third term here I can take common probability of B complement. 1 plus probability of A minus 1 B complement. What we know is 1 minus probability of A is equal to probability of A complement. Here it is probability of A minus 1. I take minus common. If it is 1 minus probability of A, this can be written as probability of A complement, probability of B complement, which is the right hand side and which is true statement. C is true. Now similarly we can check for the D option. It is given AB are disjoint. If AB are disjoint, what can we say regarding probability of A union B? I can say if AB are disjoint, probability of A union B is equal to probability of A plus probability of B. If it is disjoint, then means intersection is 0. If intersection is 0, according to addition theorem here, minus this term will become 0 here. Hence I am getting this one. Now by using this C option, just now we have proved that probability of A union B is equal to this one. Then this RHS, if I simplify, RHS will become 1 minus probability of AC probability of BC. This is equal to probability of A union B. So I can say that this I have proved when under the condition that these are not disjoint but they are independent. Now in this LHS it is equal to this when they are disjoint, and here it is only when it is independent. And independent and disjoint both are having a main difference. If it is probability of A intersection B equal to 0, it is for disjoint, and probability of A intersection B is equal to probability of A into probability of B. This is for independent. So right side expression is true only for independent, and whereas left side expression is this one which is for disjoint. So LHS and RHS cannot become equal. Hence these are the 4 options.